the elongation of spring and the time taken. Because the displacement and damping to none. For this example, we use 100 gram, hang a mass first, and we use the ruler and a stopwatch. So firstly, we measure the length. The length is 170 millimeter. And then put the mesh downward and record the temperature for 25 oscillation. So the temperature for 25 oscillation is 19 seconds. Thank you.
Assalamualaikum and good evening. Today I'm going to show you on how to measure using a mass and springs. As you can see here, this is the spring and then this is the mass. This is the value of the mass, so we can change the value right here. This is the one, the orange one, and then we have the 4 option right here, and we have the gravity, damping, and then we have the velocity acceleration, and we have one of these are the ruler and one is the time taking. So the first thing is you want to set the damping to 0, and then you need to set the displacement right here. You need to tick the right here at the first one. So the reason why you need to set the damping to none, because if, like example, I put the mass at the bottom of the spring, as you can see, the spring, the stretch of the string will constantly go up and down, so it will not stop until I take away the mass. And then if you want to find the elongation of spring, all you have to do is, for example, let's say I change the mass into 100, for example 100. Yes, first of all you need to click the pause. This is the pause button, and then all you have to do is put the mass. You must be put it right off the line of the blue right here, and then you need to take out the ruler. This is the ruler. The ruler is on centimeter, so if you want the elongation of spring, you need to convert it to milliliter, and then you need to set it to slow, so you can see the stretching of the spring. And then you can start clicking. Alright, so I click again, so we know which one the string and the spring is stretched. So right, so as you can see here, this is the stretch of the spring. This is the elongation of the spring. And then after that, we know the length of the stretching spring. We use the ruler to measure the value of the spring. So because of this website cannot be zoomed, so we need to watch very carefully, and the answer is 34 cm, 34 30 33 cm. So to convert it into milliliter, so you have 330 milliliter. For another example, if I change it to, let's say, 200, so first of all I need to click the pause button, and then we need to set to slow, and then you need to put the mask, make sure it same line as the blue one, the blue line one, and then we're gonna start the spring movement. Alright, so I stop it because I already know the length of the spring, and then as usual we need to put the ruler, so we need to measure the elongation of spring, and then you need to look very carefully the value. The answer is, the value of elongation of spring is 66 cm. If you have to change it to milliliter, which is 660 milliliter. So that's all for it. Thank you very much.
Assalamu alaikum wa rahmatullahi wa barakatuh. I'm Rabi Akbara. Today I will show you how to solve this. To read this, first you can put the mass you want. I will put 100 gram, and you can put it here like this. Stop it. Here you can control the spring constant, maybe small, large. I will put it like medium. Here you can see displacement is period is lead to the length of spring. Can use velocity, acceleration, here the gravity, and damping. I will put it none. And you can use this to accelerate the spring length, and timing here. When you put this like this, move it, you will see the yellow arrow is the acceleration and green is the velocity. And that's it. You can put it normal or slow like this, and here, then that's it.
Assalamualaikum warahmatullahi wabarakatuh. My name is Omar Muhammad Ghazali. I'm going to show you how to find the values for part B. So first thing first, we must set the mass to 0.1, select the friction to none, and open the stopwatch. So we must set the degrees to 50 degree. We must pause first, click start. Then we count the swing. So so if you want to count the number of swing, it should be from this point to this point and this point. That means one swing. Okay, thank you.
Hello and Assalamualaikum everyone. Today I will be conducting the lab for determination of gravitational acceleration. In this case, I will present to you for the part B. This lab shows us of simple pendulum. Okay, first of all, we need to configure the length of the string will be 0.1 meter and the mass of object will be 0.5 kilogram. Okay, stopwatch over there is to show the time taken for the object completing 25 oscillations. But for this video, I only showed only 5 oscillations. Alright, first of all, we need to drag the object into 50 degrees. Alright, then we start the stopwatch and then play the simulation while counting until it reaches 5 oscillation. 1, 2, 3, 4, and 5. Okay, it will be taking the object for completing 5 oscillation is 3 seconds and 33 milliseconds. Alright, that's it.